Okay, hi there. Today, for pre-calculus, I'll be teaching about graphing rational functions with slant asymptotes. So the last video we saw asymptotes that were vertical and horizontal. Today we're going to look at the slant ones. So the first thing is if the degree of the numerator is exactly one more than the degree of the denominator, then you get a slant asymptote. Okay, which is what I just wrote right here and below it. I wrote out an example up here just so we can kind of see one. If I had this example, f of x equals x squared minus x over x plus 1, you can see the numerator has the higher degree. That one's got an x squared, this one's got a regular x, which means that the numerator has the bigger degree, and therefore we're going to get a slant asymptote because of that. Okay, so I'm looking for the equation of the diagonal or the slant asymptote. Okay, and in order to do that, I'm going to divide the denominator into the numerator. Okay, like I did here. Now, your book says to do it by long division, so I did it by long division. However, if you can divide by long division, you can usually do it with synthetic division. So that's what I did here. Was I took the x plus 1, right, which would have negative 1 as a 0. If I took x plus 1 and set it equal to 0, you get the negative 1, right? And then did the synthetic division. So the x squared minus x is the numerator, so that's where the x squared minus x is right there. And then I got a 0 after that because there's no regular number, so you got to plug a 0 in. And then I did synthetic division, all right? And you get x minus 2, okay? And it doesn't have to go in perfectly, it's really what you get, what's left, how many times it does go in. So x minus 2 is what you're dividing by. And obviously I think we'd all probably prefer to do synthetic division over long division. The only time it wouldn't work is if you had like a quadratic. If you're in the denominator, you're dividing by that, then you'd be stuck doing long division. Okay? So anyway, you can see that this is a marvelous graph. Not very perfect by any means, but this would be the line y equals x minus 2. And you can see that it's a slant asymptote. And then I also have a vertical asymptote with this one, which would be x equals 0, okay? Sorry, the vertical asymptote would be x equals negative 1 because you take the denominator, set it equal to 0, and you get the vertical asymptote. All right, so those are my two asymptotes, and then I put the curves in there. Anyway, that's how you do these. So that was like an example problem. I'm going to do the real one, start with this one. Okay, so the first thing I'd like to do is the vertical asymptote, horizontal asymptote, and the slant asymptote. So I got potentially 3 of them. Let's see. So the vertical asymptote is where I take the denominator, set it equal to 0, which is x equals 0, right? The horizontal asymptote is what I get when I take the numerator and I set it equal to 0, which in this case you get negative 1 equals x squared, therefore x equals the square root of negative 1. So there is none. Okay, so there's no horizontal asymptote. I'll write none instead of undefined. The slant one is what I get when I divide. So I'm going to go over here and go x squared plus 1. Oh, I'm going to do synthetic division, not long division, which means I got a 1. There's no x, but there's a 1, so that's what x squared plus 1 turns into. And then x is just 0, right? X equals 0. So do synthetic division. 0 times 1 is 0. 0 plus 0 is 0. 0 times 0 is 0. 0 plus 1 is 1. All right, so I got x, which means my slant asymptote is y equals x, okay? Because remember, this would be x plus 0. All right, so I got my slant asymptote, and I'm going to do my quick sketch here. And so y equals x is a diagonal line that goes straight up through there like that, okay? And then the other one, my other asymptote is x equals 0, which is a vertical line going through the y-axis. I'll just put it right kind of next to it here, okay, going right over it. All right, and if I, since there were no x or y intercepts, because there's no way for me to make that numerator 0, so therefore it's not, it doesn't have an x-intercept, and the y-intercept is, if I plug in 0 for x and I get 0 in the denominator, so that's undefined, which means if I look at this graph, the only way that's happening is if I have these two quadrants be my curves, okay? So that's what I get with that one. Next one, this one, number 2. So vertical asymptote is what I get when I set the denominator equal to 0. So that's x equals 0. Horizontal asymptote. So I wrote down a quick refresher over here for which one's vertical, which one's horizontal. Remember vertical, and you should have this from the last video, but in case you were stuck. Vertical asymptote, set the denominator equal to 0. Horizontal asymptote, you have the highest degree. If it's in the numerator, then there's no horizontal asymptote. If it's in the denominator, then y equals 0. And if it's the same degree in top and bottom of the ratio, then you use the ratio of the coefficients. All right, so just a quick refresher on that. So this is the horizontal one, which means the highest degree in this is in the numerator, which means there's no horizontal asymptote. The slant asymptote is what I get when I divide. So I got 1, 0, negative 4 for x squared minus 4, and the denominator is 0 once again, so if I do quick synthetic division, I get 1 times 0, 0, 0, 0, 0, negative 4. So it's really this. I got a remainder of negative 4, and this is x plus 0, which means it's x. So y equals x. Okay, so that is my slant asymptote. Okay, so I got to fill in a couple of these. If I plug in 0 for x, I get 0 squared minus 4 over 0, so that's undefined. And if I plug in 0 for the y, or the f of x, I'm worried about the numerator. I mean, remember, I talked about this in class some. You know, if you're trying to set that fraction equal to 0, really the only thing I'm worried about is the numerator, okay? So if I add 4 to both sides, take the square root, I get x equals plus or minus 2. So those are my x-intercepts. Okay, so quick sketch. Do it over here. And let's see. So I like to do my asymptotes first. I'll do those in orange. So it's x equals 0 is a vertical one. So that goes right down this way. I should do dotted line probably. Okay. The other one is y equals x, which is a nice diagonal line going straight across that way. All right, so there's my asymptotes. And then I have to figure out, it's the curves are either going to go, they're always diagonal from each other. So they're either here or they're going to be the other one, which would be like purple. One of those two, all right? In order to figure out which way it goes, that's where I use the x and the y intercepts, okay? So the only ones I got are the x-intercepts, which are plus or minus 2. So if I go over there to plus or minus 2, let's say here's negative 2, and then here's positive 2. All right, so now I know which quadrant it is. It has to be over in this part, okay? And this one's going to go down here to that part, okay? So that's how I know which quarters. The graph's always kind of broken up into quarters, kind of quarters. That one's not perfectly broken up, but hopefully you get the idea. All right, so number 3. This one, fx equals x cubed over x squared. All right, so once again, vertical asymptote. Okay, so Number 3, if I took this one and I'm looking for the vertical asymptote, remember vertical asymptote is where you set the denominator equal to 0. So that would be x squared minus 4 equals 0. And if I solve that, I get x equals plus or minus 2. Okay. So I got 2 of them, which is kind of interesting. Horizontal asymptote is when the numerator is bigger, there is none. Okay, and the slant asymptote is what I get when I divide. So if I go x cubed and I'm dividing by x squared minus 4, maybe we'll do this one by long division. You know, you go on x cubed divided by x squared, that's x. So if I take x and I multiply it by x squared minus 4, I get x cubed minus 4x. Okay, and then I'm bringing down the 4x, but x squared doesn't go into 4x. So this is actually what it is. It's going to be y equals x, all right? Because I'm done at that point. There'll be a remainder. This is the way that works, okay? So let's see. If I plug in 0 for x, I get 0 over 0 squared minus 4, which is negative 4. If I plug in 0 for y, I get 0 equals x cubed, so that one will be 0. All right, so let me get my graph going over here. And asymptotes, so I got vertical ones going up and down through 2 and negative 2. And over here at 2. And I've also got, I got no horizontal one, but I got the slant one going through y equals x. So this is kind of interesting. Okay. So I got my 3 asymptotes. The other thing that I noticed here with this is I got these x's. I got x squared times. Okay, so here we go. This goes right through 0, 0. All right, so I know that this one's coming down and it's going to hit the 0, 0, and then it's going to go down towards the other asymptote. All right, it's also going to be triple 1. So I got 1 up here, and I'm going to have 1 down there. Okay. That's the way those are, you know, as far as like you had to go through 0, 0, and I know there's that asymptote there, but that's really for the other 2 curves, okay? But notice how all 3 of them are diagonal from each other. So anyway, that's what that one looks like. All right, if you got any questions on that, please bring them to class. All right, next, we're going to be solving linear inequalities, new topic. All right, so don't fall into this trap over here on the right where I wrote down, you know, the x squared minus 4 is greater than or equal to 0. You know, add 4 to both sides, take the square root. That doesn't work with these, okay? We've got to go with these a little differently. So, you know, I know if I factor that, that's a difference of 2 squares, x plus 2 times x minus 2, all right? And then what I get is those 2 values, right? You know, the 2 and the negative 2. So there's really like 3 possibilities here. You know, I could get some solutions in here between 2 and negative 2, or I could get some solutions out here which are greater than 2, or I could get some solutions that are less than 2. And what I'm looking for is, obviously, since this is greater than or equal to 0, I want to know where they're positive. Okay, so what I would just generally do is I take an easy number between in each of those intervals, pick an easy number between negative 2 and 2, so I'd plug in like 0, all right? And if I plug in 0, I get 0 plus 2 times 0 minus 2. Is that, you know, positive? Is it negative? Is it greater than or equal to 0? You know, that's 2 times negative 2, which is negative 4. So that's not, I get negative there. I'll put a negative here. Now, if I plug in 3, 3 is easy too, right? 3 plus 2. If I go with, change the color, 3 plus 2 is 5. 3 minus 2 is 1. 5 times 1 is 5. So that's positive. So 3 is good. I get positive numbers. That's a good one. What about negative 2? That's my other, or negative 3. We'll do negative 3 instead. If I plug in negative 3 for x, I get negative 3 minus 2 is negative 1 times negative 5. So that's positive. So that's also good, which means, that my solution here is it's good from negative infinity all the way up to negative 2, including negative 2. It's good from 2. If I plug in 2, I get 0. That's greater than or equal to 0. So it's good from 2 to infinity also. Okay, so those are my two solution sets, okay? And that will make my solutions, okay? Next one, number 3, x squared minus 3x minus 28. So I need to factor it. Let's see, things that multiply to 28, negative 28, and add up to negative 3. 7 and 4, yeah, x minus 7, x plus 4 is greater than 0. So once again, I've got my values over here. Negative 4 over here and 7 over here. Think of it like parentheses, So if I plug in 0, I get negative 7 times 4, which is a negative number. So that's good because I'm looking for the numbers that are less than 0. So that's good, which is a good solution. Now let's take another number. Let's say I take 8. I'll plug in 8. Change colors. So if I plug in 8, 8 minus 7 is 1. 8 plus 4 is 12. That's a positive number. And that's not going to be a solution set for me. Let's check negative 8 and see what happens over there. Negative 8 plus 7 is negative 15. Negative 8 plus 4 is negative 4. If I multiply those together, I get a positive number, which is not the solution set for this because I'm looking for things that are below 0 or less than 0, which means it can be between negative 4 and 7. And if I plug those in, I get 0, which is should not be included here, I believe. So should get parentheses around those. All right. Yeah, okay, so next one. 6. So this one, you want to have the 0. It really makes life easy, okay? So subtract 9, don't subtract 8. Subtract 9 from both sides, and I'll get x squared plus 4x. 4 minus 9 is negative 5. Is greater than 0. Remember, if you ever divide both sides by a negative number or multiply by a negative number, you flip the arrow the other way. All right, so I get x plus 5 times x minus 1. That's what I get when I factor. Okay, so I'm going to go down here. I'm going to make my number line. All right, I'm going to put negative 5 and positive 1. And then I'm going to pick some numbers in between. So I like 0, for example. If I plug in 0, I get 5 times negative 1. Is that greater than 0? No, that's a negative number, so that one's not going to be in my solution set. What about 2? If I plug in 2, I get 5 plus 2 is 7. 2 minus 1 is 1, so that's a positive number. That one's good. And last but not least, let's try a negative number. We'll try negative 6 down here, see what happens there. I get negative 1 when I plug it in. Negative 6 plus 5 is negative 1. And negative 6 minus 1 is negative 7. Oh, but that's a positive number when I multiply them together. So my solution set, once again, will be like all these numbers going from negative infinity to negative 5. Negative 5 is not good, so I'm going to put a parentheses around it. That was supposed to be an infinity. I don't know why I put 8. Must have been the infinity's a sideways 8. Had a brain cramp. All right, not including that one. And then it starts up again at 2. Does it include 2? Oh, sorry, it starts at 1. My bad. I was looking at my number. All right, so it starts at 1. If I plug in 1, I get 0. So that's not included because I get 0. 0 is not greater than 0. If there was an or equal to, then it would be good. and that goes all the way to positive infinity. Infinity is not included either. Those are my answers. All right. All right, this one. So if I'm doing this one out, I'm going to have to FOIL this out. I want to get that 25 out of there. If it was greater than 0, it would be easy. Okay, but if I FOIL this out, I get x squared minus 8x plus 16 is greater than 25. Now I subtract 25, and I get x squared minus 8x. 16 minus 25 is minus 9. All right, there we go. Now I'm ready to factor and get this going. If I factor this, I get x minus 9 plus 1. Multiplies to negative 9, adds up to negative 8. So I'm going to make my number line, and it's going to be over here at 9, and 9's on the positive thing. And negative 1's over here. So if I plug in some numbers now, I still love plugging in 0. It's the easiest number to work with. 0 minus 9 is negative 9. 0 plus 1 is 1. Multiplying together, you get a negative number, which is not a solution. I need things greater than 1. And if I plug in 10, 10 minus 9 is 1 times 11. That's a positive number. And if I plug in negative 2, negative 2 minus 9 is negative 11. Negative 11 times negative 1 is what I get when I plug in negative 2 over here. So that's a positive. So my positive numbers are my solutions, which means it goes up to negative 1, not including 1. And then it starts again at 9 and goes all the way to infinity. And neither one of those is included. So those are my answers. Okay? All right, this one. This is a draw a line down the middle kind. All right? So I can still factor. You have to factor these. That's really the only way I'm seeing these happen. So if I pull out an x squared over here, I'm left with x minus 3. If I pull out a negative 1 over here, then I get x minus 3, which means I get x squared minus 1 times x minus 3 is greater than 0. Now, x squared minus 1, that can be factored. That's a difference of 2 squares. That's x plus 1 and x minus 1. And then I've still got the x minus 3 as well. All right. Okay, so this one, just got a bigger number line. A couple more numbers to plug on in here. So I got negative 1, I got positive 1, and I got 3. Okay? So now I'm going to plug in some numbers. Here goes negative 2. If I plug in negative 2 over here, I get negative 1, negative 3, negative 5. So I get I get a negative. First two negatives multiplied together give me a positive, and then positive 3 times negative 5 is negative 15. Okay? If I plug in a number here, which will be like 0, I get 1 times negative 1 times negative 3. So that's a positive. Positive, two negatives together make a positive. And if I plug in a number over here, like 2, I get 3 times 1 times negative 1. That's negative. And I got to do 1 over here also. So if I plug in 4, I get 4 plus 1 is 5. 4 minus 1 is 3, and 4 minus 3 is 1. So those are all positive. That's going to be a solution. So my solutions are between negative 1 and 1. Are they included? I get 0, 0, and I get a negative number. So they're not included. And I also got from 3 to infinity also works. Okay, so those are my solutions. All right, you try this one. 4x cubed minus x squared, 6x squared, all right? Try that one and bring it to class. Looks like I was kind enough to give you an answer over here, okay? So there's what it should have come out like. And I got one more here. This one's kind of crazy because not everything's factorable, right? So I did this one out, just to play with it. And I'm doing quadratic formula. Okay, I can still find the values. They're just not going to be whole numbers. All right. So if I actually solve this out, you get -8 plus or minus the square root of 84 if you do that whole thing out. Right. A is 1, B is 8, C is -5, negative B plus or minus square root of B squared minus 4AC all over 2A, quadratic formula. And if I do that out, I get the decimals. I get either -8.583 or I get x equals 0.583. All right, so those are my two numbers, which means if I go over here to my number line and I plug them in, okay, so I got -8.5. And over here I got +8.5. And then I can plug them in, all right? Plug them back in there and see what you get. If I take, let's take an easy number. If I take 0, 0 squared plus 8 times 0 minus 5 is -5. So that's not good. That's negative. What about if I take, remember you get to pick your numbers, so pick wisely. If I pick -10 is pretty good. That would be -10 squared is 100. 8 times -10 is -80 minus 5, so that's positive. And if I pick +5, I'll get the same thing, except that's going to be +80, which would give me a positive. So the middle part doesn't work. The ends do. Goes from -infinity to -8.583. That one's included, this one's not. And then it starts up again at, this should have been 0.583. Sorry, I wrote that wrong. 0.583. So it starts at 0.583 and then goes to infinity. This one is included, that one's not, okay? So those are your solutions, all right? So anyway, I figured I'd show you one of those. All right, that's all I got for tonight. Have a great night, and I'll see you all soon.